Good evening. This is 8:30 Prep, a production of 3R Prep. I'm Phil McCaffrey, one of the co-founders of 3R Prep, and this is my producer right behind the camera, Damien. Say hello. Oh, he said something without me asking him. Say good evening, Damien.
Sorry, hello.
So, today is March the 16th, and the entire United States is shutting down because of the fear of the coronavirus. And I have been busy tutoring online, working with teachers, rearranging classes. It's been an exhausting day. I've been in here already 10 hours. But what we're going to do is work on ACT math formulas on the foundational level. And what I'm calling the foundational level is about an ACT score of 25. I'm going to lose my words today. This is going to be great. I've been talking nonstop for 10 hours. An ACT score of about 25, which equates to an SAT score of about 1,200. So a 600 on the SAT math, a 25 on the ACT English. And we're going to look at some of the things that overlap and some of the things that are specific to the ACT. What I'm doing is writing a math book, as if I didn't have more things to do. I'm writing a math formula book because the one thing that I haven't been able to find on the market is a good book with just the formulas short enough for a teenager to read. Most of the books are just way too big, so I thought I'd make one of a decent size that a teenager might actually read. So let's get started today. One of the things I wanted to talk about was, unfortunately, tests are being canceled. But there's a really good news about the ACT, and that is starting in September of 2020, let's hope that the COVID-19 is behind us by September of 2020. But on the September 12th, 2020 ACT, the ACT is going to initiate superscoring and section retaking. And what a superscore is if you take a full battery, that is all 4 sections of the ACT at once, as a full test, and then take another test or another section, the ACT will pick the highest score per section for your test. And then when you send off your super score, what the college will receive is a super score of all of your best scores and then your highest one day. So it will receive whatever the college wants. So whatever your highest composite is and whatever your super score composite is, they will send it both, and the colleges can choose what they can upload. I think colleges will adopt the super score, and I think the ACT has made this a total game changer, and I really like it, so that students can focus on taking the test several times and working on strengths and weaknesses and building up a score and put their best foot forward. The other test dates for the ACT, if you are a junior and you are in the class of 2021 to apply for normal admissions, are April, which... Sorry, folks. I think that's going to be canceled. I think if I check the news, I think this probably would have already been canceled today. I do believe the SAT has officially canceled the May test already. There is a June test, there's a July ACT, and there's an October, which is, of course, after the September test. So we still have 4 more chances of a decent ACT test before normal college admissions. I also think because of the coronavirus epidemic that college admissions are going to be delayed for the class of 2021. So those students that are graduating next year are going to have some extreme flexibility in their deadlines. All right, let's talk about, let's not talk about that. Let's talk about ACT math. So I'm writing an ACT math formula sheet. The ACT has a very standardized approach to math. It's very beatable. I like the test very much, and there's a lot of reasons, and I'll talk about a few of them. The one is that the ACT allows a calculator for the entire test. Old-fashioned math teacher that I am, I would like my students to be able to do fractions by hand, but let's face it, when will you ever be without a calculator in your life? When will you ever be without this device? You won't. Even if you're in the Himalayan mountains and have no service, as long as it's warm enough for your phone to work, the calculator is built in. So students have grown up with a calculator. The ACT allows a calculator on every test question. The SAT has a non-calculator section. I don't completely understand that. I don't understand why. So let's go over ACT Math Review. This is me talking through what I want to write in my book. And the first thing is, the ACT math is simple. It's add, subtract, multiply, and divide. I mean, it is add, subtract, multiply, and divide. And I have a few key rules that I follow. I have Phil's 4 rules, and my wife made a beautiful poster for me that's upstairs in the tutoring student. The first one is read with your pencil. If you notice as I'm going to the screen, I like to underline things and read with your pencil and underline keywords. Slow down. The human brain works a lot faster with words than the human eye can decode word symbols. Words are sounds, and words that are written on paper are the symbol of sounds. So what your eye is doing is taking the symbol of the sound, like a W, and translating it into that sound in your brain. That happens really quickly, and most people it happens intuitively. But your brain can think a lot faster and can hear a lot faster than your eyes can interpret words. So what happens when you're reading? You skip over, you guess ahead, you fill in. When you're reading something, have you ever read a passage, a book, a newspaper, a clipping, if you're reading something detailed and you got to the end of it and you didn't remember what you read? We've all had that experience. What's going on there is your brain isn't engaged. That's most likely because you're being a passive reader. You're not being an active reader. And the thing about the ACT is if you take it on paper, because computer testing is coming, I like the paper better because you can put an old-fashioned pencil in your hand, even though this is a computer stylus. You can put a pencil in your hand, you can touch the test, and you can underline keywords. So underline key math words. What do the key math words mean? Add, subtract, multiply, or divide. For example, the word bisect. It shows up on almost every SAT. If it doesn't show up, halfway shows up. But what does bisect mean? It means halfway, or half. It also means midpoint. And the midpoint between 2 points on the coordinate plane is the average. What these words are equated. The ACT uses a thing called an equating formula. So these words are equated. They all mean the same thing. I was working with a student today, and he missed 3 questions that all had something to do with cutting in half or being in the average. And at the end of it, he felt really embarrassed. It was an excellent lesson that he's missing the same thing, because now we could go in depth of it and look at the words and see what the key math words were and divide. And in the end, he just realized he just had to divide in half and cut the words in half. Rule number 2, write an equation. The thing is, too many students are trying to speed up on the ACT. When you are doing every single problem, write an equation. And I've got a tickle in my throat and I have to cough, and I'm on live streaming. So I wonder what television personalities do to keep their throats from jamming out while they're talking live on the news and all that.
I have a mute button for you.
And I have a cough drop in. I'm coughing and Damien's in the room, and that scares me.
I muted you.
Right? Did you mute me? Write an equation. Write down an equation. If it is the area of a triangle, write down 1/2 times the base times the height. Write the equation down. If it's the circumference of a circle, write 2 pi r. If it's the area of a circle, write pi r squared. The thing about 2 pi r and pi r squared is they all use the same exact numbers. And these will be in there. So if the radius is 6, this is 12 pi. If the radius is 6, this is 36 pi. They don't use units. They don't say 12 pi radians or 12 pi centimeters, or they don't say 36 pi centimeters squared. They leave that in the question, and they just leave the numbers in the answer. So the students get the answer incorrect by using the wrong formula because they just do it in their mind. Write down the formulas, and that's why I'm going to be so focused on writing a formula sheet. The second part of rule number 2 is do math like it was in like you were in the 7th grade. That is, do every step. We all skip steps, and I'm terrible at it too, and I'm a math teacher. I distribute negative signs wrong, I add instead of subtract, and I'm a little bit dyslexic. So the one thing that I have to do when I'm doing math is be very, very careful. The reason that I'm pretty decent as math is because I practiced a lot, and I have my father to thank for that. Rule number 3, draw a picture. There are a lot of geometry questions that are given in words without a picture, like a circle, and points on the circle are clockwise or counterclockwise. Well, if it says points on a circle, or 5 people are standing around a circle, draw the 5 people standing around the circle. That's an actual ACT question where it says 5 people are standing around the circle passing a ball. And the rules are you can't pass the ball to the person next to you. So pass the ball, and these are the people standing next to it, so he passes the ball here, and he passes the ball here, and he passes the ball here, and he passes the ball there, and it wants to know how many passes does it take to get back to the original person. If you look at the picture I draw, you see it's very easy. It's 5. Students miss this question all the time, and I ask them, where's your picture? And they look at it and they say, huh? I said, the question said 5 people standing around in a circle. Draw the circle. Lastly, the ACT has an advantage over the SAT in that it is all multiple choice. Use the answers. Everybody knows in multiple choice to work backwards. This is also called back solving, and that is if there are numbers in the answer choices, plug them into whatever the question whatever the question says, and use your calculator. That was also part of rule number 2 that I skipped over. Use your calculator. You have a calculator. It does arithmetic better than you. Practice using your calculator, particularly the things on the TI-84 that I really love, which is this button right here that says Math. This is full of formulas in the way of doing things, like turning decimals into fractions or using absolute value. Plug in your own numbers. If there are variables in the question and variables in the answer, you can plug in your own numbers. For example, if the question said x minus 3 over x plus 5 is equal to which of the following, you can literally plug in 0 and get this to equal negative 3 over 5 and compare it to the answers. That's one of the videos that if I haven't done, I'm definitely going to do, which is a complete lesson on plugging in and doing rational functions. Finally, estimate. Estimate. Figure out what it looks like. A lot of times I've asked students to estimate the problem. What does it look like? Today I was working with a student on a circle, and the radius was 52, and it said approximately, or which was the closest. Well, if it's the closest, and it wanted to know the area, so you did 52. I did 52 squared times 2, and I got an answer that was close. All of the answers were completely off. I didn't have to go through and do second function pi or 3.14. I literally did 52 squared times 3, and I got close enough, and I got the right answer. Even with your calculator, you can estimate. What does the ACT use? Let's start at the basics. I break the SAT and ACT questions into what I call concepts, and there are 6 levels of concepts. The first one is numbers and operations, and this is what you learned in elementary school and middle school before you got into algebra. It's the things that we do with numbers, and the first thing is numbers have names. On the ACT and the SAT, all the numbers are real unless stated otherwise. Well, if stated otherwise, they would be imaginary, and that is the imaginary number I, which is equal to the square root of -1. On the SAT and the ACT, there is only ever one or two imaginary or complex questions at the most, usually just one. And on the ACT, it hasn't shown up 100% of the time. So it's about what I call an 80 percentile question. But all of the other numbers are real. What are real numbers? They are numbers that you can physically use. And those are broken into rational and irrational numbers. And then a subcategory of rational is integers. What is a rational number? This is a fair word. Which one of the following is a rational number? A rational number is a fraction of integers. A divided by B, where A and B are both integers. These are numbers that can be written as fractions. What are irrational numbers? They are numbers that cannot be written as fractions. If you plug them into your calculator and you did the square root of 2, there is no fraction that you can turn it into. Now there's an estimation, like pi being 22 over 7, but that's an estimation. Pi is an irrational number. The three big irrational numbers that you need to know are pi, the square root of 2, and the square root of 3. They use the square root of 2 more than any other irrational number on both the ACT and the SAT. And finally, the number one word given on both tests is integers. What is an integer? An integer is a whole number and a whole negative number. Whole numbers aren't negative, but negative numbers are less than 0. So we're talking about -3, -2, -1, 0, 1, 2, 3, and going on forever like that. There are numbers without fractions or decimals. I know you could write 3 over 1 as a fraction, but nobody does. This is an integer. An integer is a number without a fraction. What do they do with integers? The properties of integers show up on both tests. They used to show up on the old SAT, which I miss dearly, and I always talk about it, and that's already 4 years ago. They used to do integer questions all the time, and that was like 4th to 7th grade level math. I made a great living out of teaching 17-year-olds what they should have learned as 10, or what they should remember what they learned at 10. What are the properties of integers? Number one, a prime number. Prime number is a question that is missed so often that it's ridiculous. Every student knows what a prime number is. It is a number that only has factors of itself and 1. But what is one of the biggest things they miss? They miss the first prime number. And the first prime number is 2, not 1. The first prime number is 2, not 1. It's worth repeating. What are the first 10 prime numbers? You absolutely have to memorize them. 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. These are the first 10 prime numbers. You absolutely have to know them. If you want a super high score, there might be a question on a difficult section about a prime number larger than 30. So Google the prime numbers less than 100. I've never seen a prime number greater than 100, but I've seen a prime number up into the 90s. So this is worthwhile. There's also a little pattern to the prime numbers as they get up, so they're easy to memorize, and it's not a hard thing. What is one of the numbers that looks like a prime number but isn't? Is 51. 51, as if you remember your rules of multiplication, 5 plus 1 is 6, so 51 is a multiple of 3. It's 3 times 17. 51 is not prime. 53 is. Odd and even. Odd numbers and even numbers are mostly used algebraically. An even number is 2 times any integer. 0, 1, 2, 3. 2 times any integer is an even number. 2, 4, 6, 8. An odd number is an even number plus 1, algebraically. So odd and even integers are used in a way that we have to do some algebra with. Positive and negative. A positive number is greater than 0. A negative number is less than 0. 0 is not positive nor negative. It is neutral. It is, however, even. So when we do even and odd numbers, an odd number is 1, an even number is 0, an odd number is -1. So if we go from -1 to 0 to 1, we go odd, even, odd. So 0 is even, but it is neither positive nor negative. The favorite word of the favorite phrase of the ACT and the SAT is positive integer, and that means the counting numbers 1, 2, 3, and 4. Consecutive. Consecutive numbers also involve some algebra, and that is a number and then the number plus 1 or the number plus 2. We could also have consecutive even and consecutive odds, which would be n and n plus 2 and n plus 3. So if we started with 3, what are the consecutive odd numbers after 3? 3 plus 2 is 5, plus 4 is 7, and so on. Factors and multiples. These words are absolutely used on the test, and it goes back to the 4th grade. A factor is the integer divided by another integer evenly. For example, the factors of 12 are 1, 2, 3, 4, 6, and 12. 12 is the first number with 4 factors besides itself and 1. And that's why we use a dozen, because you can split a dozen into 2 parts, 3 parts, 4 parts, or 6 parts. Our number system is based on 10, and I believe it's based on 10 because we have 10 fingers. 12 is a better base system. You can do more math with 12, but we do math with 10. But we also do math with 12 right here. You do math with 12 every single day. Notice there's 24 hours in a day split into 12 hours, AM and PM. So 12 is a very powerful number. Multiples are greater than the number. Factors are the number or less. Multiples are the number or higher. So the multiples of 3 are 3, 6, 9, and 12. That is an integer multiplied by integers as it increases. They also like the square of an integer, and the square means the number times itself. I know decimals and irrational numbers can be squared, but they mostly work with integers. Rational numbers can be squared, but they mostly work with integers. So the square of an integer is something that you absolutely need to know. And the first perfect squares are 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 25, 36, 49. And so on, 64, 81. You need to know the perfect squares. Why? Because they also ask square root of. Students mix these two things up all the time. The square root of 25 is equal to 5. They also ask stuff like the square root of 50. The square root of 50 is equal to the square root of 25 times the square root of 2. The square root of 25 is 5, so the square root of 50 is 5 root 2. That is a problem that comes up a substantial number of times. And lastly, remainder. This is one of my favorite problems. I really enjoy doing remainder problems, and it's shown up on the last couple of ACTs as repeating numbers. So it's a decimal that you have to divide into. A remainder would be like 3 divided into 7. 3 goes into 7 2 times. 2 times 3 is 6. The remainder is 1. There's more on that, and I'll do it with some solutions. To the ACT only goes sequences. I don't know if I said that correctly. Sequences are only on the ACT now. Since 2014, I have not seen a sequence problem on the SAT. They have dropped it as one of their concepts. But on the ACT, I've seen a sequence on almost every test. It's a 100% problem, and it's either an arithmetic sequence or a geometric sequence. A geometric sequence shows up about 60% of the time, maybe 2/3 of the time. 1/3, 40% of the time is arithmetic sequences. An arithmetic sequence is a pattern of numbers where the difference between the numbers is the same. You add or subtract the same thing. So an arithmetic sequence would be 2, 4, 6, 8. The geometric sequence means multiply or divide. And like I said, it shows up more often on the ACT than the arithmetic sequence, and that would be 2, 4, 8, 16. What did I do on the top one? I added 2. What did I do on the bottom one? I multiplied by 2. That's the difference between an arithmetic and a geometric sequence. The other thing you need to know is the numbers in the sequence, and that is an arithmetic sequence. I can find any number in the sequence if I know the starting number, a sub 1, plus the common difference times the number minus 1. This is a formula that you should know. It comes up about once every 4 or 5 tests, but it's worth knowing. For a geometric sequence, let's change colors on geometric. This is arithmetic. A geometric sequence would be a sub n is equal to the first number multiplied by the common ratio raised to the power n minus 1. And as I do this formula sheet, I will do them over again and start giving some sample problems. Right now I'm just going through the formulas. Ratio. Ratio, 100% on the ACT, and it's almost always part to part. A ratio works like a fraction in that it takes a larger number and it reduces it to a smaller understanding. So it'd be something like this, 2 to 3. The colon stands for the ratio. We could also write the word 2 to 3. We could also write a ratio as a fraction, 2 to 3. It's not a fraction where it's a numerator and denominator. It's a comparison of two numbers, but we can write it this way. Ratios can also be 3 or 4 numbers in comparison, and we wouldn't write those as fractions. We would only use the colon. This is one of my favorite things to study because when I learned from the Princeton Review how to do a ratio, I have never missed a ratio problem since then. And that is, if the ratio of boys to girls is 2 to 3, you draw a thing called the ratio box. And the ratio box says that there are 2 parts to 3 parts, so that there are 5 parts total. There's going to be a multiple of 5 parts because ratios are a reduction of a large comparison. So if I said there are 25 students in my class and the ratio of boys to girls is 2 to 3, then what I do is have a multiplier. 5 times 5 is 25. 3 times 5 is 15. 2 times 5 is 10. And let me put in a little politically correct note right now. The SAT and the ACT, mostly the ACT, still is binary in that there are men and women, boys and girls. There is nothing beyond the binary genders. I think we're going to see an end to that, and they'll mostly transition to like fruit salad where there's oranges and apples and bananas instead of boys and girls or men and women. But those problems still exist in practice. So, ladies and gentlemen, I'm sorry, on the ACT, there are only men and women. There are no transgender or non-gender specific people. It's a binary. Percent. This is one of the most missed questions on the ACT. Percents and averages, and we're going to get to both of them. A percent means per 100, out of 100. So per means out of, cent is Latin for 100. Like there are 100 pennies in a dollar. There are 100 cents. Or a centurion was a person who was in charge of 100 soldiers. A century is 100 years. Percents are extremely easy to do, but tricky on the SAT and the ACT. What they like is a percent increase or a percent decrease. The question could be something like this. Phil went to the store and bought a computer. It was 25% off or 25% discount. He paid $500. What was the original price? So we take the original price, the unknown X, we multiply it by the price times the discount, subtract the discount, equals the $500. Students miss this problem all the time. You need to know how to multiply a percent times an increase. If it's 25% increase, you multiply by 1.25. If it's a 20% decrease, you multiply by 0.8. That's 100 minus 20%. The SAT loves this question where these formulas are the answers. So you don't actually do the percent, you see how to set it up, and students get lost on it. So if I took a problem and I said, I started with a number and I increased it by 125%, excuse me, if I increased it by 25%, and then I decreased it by 20%, I multiply by 1.25 times 0.8. What happens when a number is increased by 25% and then decreased by 20%? It stays the same. The wrong answer is that it increases by 5%, 25 minus 20. Percent always means multiply if they're asking for the answer. If they give the answer, it means the inverse of multiplication, which is divide. Percent never means add or subtract. You always have to multiply or divide on a percent question. Inequalities. This comes up all the time, and that is one number is less than another. 2 is less than 3. Let me give you an inequality problem. X plus 2 is less than x plus 3. You solve inequalities just like you solve any other algebra. You subtract x from both sides, and you get 2 is less than 3. So this works for any other number. If I turned the problem around and I said x plus 2 is greater than x plus 5, and I got rid of the x's, 2 greater than 5, there is no answer. There is no number that I could put in here and solve for it. But they love inequalities. They graph inequalities where there's a circle and then the number, or a circle filled in greater than or equal to. There's at least or at most. These are things I'll go over in another lesson. Absolute value. Absolute value means the number's distance from 0. So the absolute value of x has to be greater than or equal to 0. The absolute value must be greater than or equal to 0. The smallest an absolute value can be is 0. So if the problem is x plus 2 is less than -1, there is no answer to this. There is no number that I could put in whose absolute value is less than -1. They love absolute values and inequalities together. I think that's going to be a whole lesson where I put together a bunch of sample solutions for that. Exponents and roots. An exponent means a number multiplied by itself, and that is x squared. A root is the square root of x, or a number to a fractional exponent. So the square root of x is equal to x to the 1/2. X squared and x to the 1/2 show up on every single test. And there are rules to exponents and roots, and that's where I'm going to start next week, because I just noticed we've gone over the time limit, and Damien didn't tell me. I told him to stop me at 25 minutes, and now I'm at 35 minutes. So this was pretty good. I'll post the PDF of this in the sheet, and then I'll add on more. So next week on 8:30 Prep, we're going to finish my ACT formula sheet, and then the following week we're going to do how to read ACT Science. I'm Phil McCaffrey. Thanks for watching 830 Prep.